From now, I'm going to talk how to use total analysis. Before seeing the total analysis application screen, this is the browsing screen of CASIA 2, which we can see after taking the measurement. There are many kinds of applications on it. Some applications are for cataract, for glaucoma, for cornea, for refractive, also for tears. And those pictures are the screen of each application. Upper left is the screen of 2D analysis, and we can see the OCT image of anterior segment and some values of that. Upper right is topography, which we can perform detailed evaluation of the cornea using Fourier analysis or ectasia screening. And bottom left is pre-op cataract application, and this is toric IOL screen. By using this application, we can calculate spherical power of IOL. Also, we can simulate toric IOL surgery by referring to some axis information. Last one is star 360 that displays the angle of the entire round of patient eye as a chart. And we can evaluate the condition of the entire round angle at the same time. Like these, there are many applications that we can use on CASIA 2, and those applications are useful for the detailed examination of target disease or part of patient eye. However, at the same time, those are highly specialized in each clinical field, and sometimes it is confusing about how to select appropriate examination or application for each patient for the first time. To solve this problem, we developed total analysis application that we can check summarized information of anterior segment on one screen at the same time quickly and easily. So, this application can be used as first application to use for each patient. And if you realized an abnormality in a part of the patient eye, you can use other highly specialized application and can perform more detailed examination. Before moving on to the details of application contents, I would like to tell you about 3 features of this application. Firstly, this application displays several of images and various parameters of anterior segment at the same time. Seeing various anterior segment information at the same time is just like as we perform examination with slit lamp. Specifically, there are 8 images and more than 20 indices of anterior segment. Secondly, the parameters of indices enable quantitative evaluation, and it is easy to find abnormalities by color coding. Lastly, we can compare the information of left and right eye, or before and after surgery on one screen. And, when the difference between the left and right eye is large, there is icon appears, and that make it easy to detect early stage of disease. Or if the amount of change, such as before and after treatment, exceeds the standard value, the color will be displayed in a different color depending on the direction of the change. Sometimes it is difficult to realize early stage disease or small changes when we refer to the individual eye information at that time only. As you may realized, there are 2 types of display of total analysis. Left one is both eye display, and we compare right and left eye in one screen. Then the difference of both eyes can be checked. Right one is differential display, and we compare before and after treatment in one screen. Then the overall changes of anterior segment due to treatment can be checked. Let us see the details in order from the top of the both eyes type of total analysis. We can see topography map on the top here, and some parameters of keratometry, real power, corneal aberration, and pachymetry. For example, if the patient has keratoconus, we can realize it from the abnormality of axial map or thinning of pachymetry map. Of course, we can refer to each parameter of keratometry, pachymetry, and HOAs and so on. In addition, please check whether the icon appears between both eyes parameter to compare the difference. Next to the topo map, there are OCT image, densitometry, and Landolt ring image. We can check angle recess, the shape of lens or cornea, and some others from the OCT image. When it comes to the angle recess, we can also check the value of AOD, which is angle open distance between cornea and iris. And there are the parameters of lens as well. Densitometry graph is for the reference of cornea and lens opacity. For example, if the patient has Fuchs dystrophy, which affects corneal endothelial cells, densitometry around the back surface of the cornea would be higher. And this Landolt image is calculated from higher order aberrations. That means this distortion on appearance cannot be corrected by glasses or IOLs. This image would be a help for patient to understand the severity of the corneal aberration intuitively. There are camera pictures of anterior segment and tear meniscus of OCT image at the bottom. We can evaluate hyperemia and size of cornea or pupil diameter by the picture, and we can check the tear meniscus from the OCT image. Also, there are parameters of cornea and pupil like white to white or pupil diameter. That is the outline of total analysis screen. So next I would like to show you some clinical cases. Next, here is the display screen for the differential mode of total analysis. The displayed images and parameters are the same, but the difference parameters before and after treatment is displayed. Or we can show the differential map and overlapped OCT image instead. A standard value is also set for the difference, making it easy to understand the changes before and after treatment. Now let's move on to introducing some case studies. Please have a look at this screen. There is abnormality of axial power on the topography map, and we can see the thinning of cornea thickness from the both of pachymetry map and parameter here. And every parameter in keratometry, real total corneal power and corneal aberration field is highlighted in yellow or red. In addition, there a red icon appears on those indices, which means the large difference between right and left eye. We can also see strong distortion of Landolt ring image. From those images and parameters, we could find the possibility of some corneal disease. This is actually a specific case of keratoconus, and there are many signs of disease apparently. However, if it was early stage of keratoconus or any ectasia, it is difficult to realize the possibility of it only by the slit lamp examination. So, it is important to evaluate quantitatively and compare to the other eye to find early stage disease. Then if there are possibility of any specific disease, we can use another specialized application. This time it is going to be Fourier analysis or ectasia screening. Here is the ectasia screening screen of this patient. This application shows 85% of ectasia similarity, and some treatment for ectasia is required. This is the patient who had LASIK surgery. Some parameters regarding cornea are highlighted in yellow or red since those values go over the standard range. On the other hand, the difference between both eye are small, so there is no icon appears between the both eyes parameters. So, we can guess those abnormality is due to LASIK surgery, not the disease. This patient, almost of all the parameters are within the reference range, however there are many red icons appear, which means the difference between left and right eye are large. Those differences are difficult to realize without comparing both eye parameters because each parameter is within the reference range and not abnormal when it is checked individually. Please have a look at OCT image and lens densitometry, which is not highlighted because densitometry does not have reference range, but the difference looks large. So, considering from these situations, those abnormality is caused by cataract or something, and some detailed examination may require for such patient. This is the OCT densitometry screen of this patient. We can see high opacity on the lens and we can suspect cataract. That was some examples of the clinical case, and I would like to summarize the main point again. This is the total analysis screen before and after treatment for a patient with stromal corneal herpes in the right eye. When we're looking at the displayed images, we can see that the pattern of the axial power map has changed after treatment. The corneal thickness map shows that central edema has disappeared, and we can see that from the signal intensity of the OCT image. Looking at the parameters, it can be seen quantitatively that HOAs have improved as central corneal thickness has improved. This is a patient who underwent laser iridotomy for an acute glaucoma attack. The OCT image shows that the angle has opened and the iris has become straight, indicating that pupillary block has been released. Looking at the parameters, we can see that ACD has improved quantitatively. This is total analysis screens before and after pterygium surgery. The preoperative pachymetry map shows that the temporal and nasal sides are asymmetric, and the OCT image shows that the pterygium has invaded the pupillary area. After surgery to remove the nasal pterygium, the corneal thickness map showed a well-symmetrical pattern, and the OCT image and anterior segment picture show that the pterygium was cleanly removed. In addition, the parameter differences quantitatively show improvements in cylinder and HOAs. As we can see from those clinical cases, thanks to the total analysis application, we can check summarized anterior segment information quickly. Color segmentation helps us to find the abnormality or changing of anterior segment easily. We can realize early-stage disease by comparing left and right eye. And we can create workflow that refers total analysis first and moving on to next step diagnosis with highly specialized application as needed. Here is summarization. Now, with total analysis, CASIA 2 is more easily to be used for daily operations such as initial examination, follow-up treatment, and informed consent, and helps doctors to maximize the use of CASIA 2. That brings me to the end of documentation. Thank you very much for your attention.